All right, we're going to do conic sections. All right, today we're going to focus on circles and parabolas. So here's the standard forms. In the following equations, the point HK is the vertex of the parabola and the center of the other conics. So in the circle, HK is the center, and then in the parabola, HK is the vertex. Notice that no matter which way we're looking, either horizontal or vertical asymptote, the H is always with the X coordinate and the K is always with the Y coordinate. So here you got X equals H and here you got Y minus K. Y minus K, X minus H. X minus H, Y minus K. So that's because it's always HK, H goes with X, K goes with Y. So this conic matches the formula X minus H squared plus Y minus K squared equals R squared. So that's a circle. So we identify our HK from our equation. They always come out kind of like opposites. You got to remember, because this is X minus H, this will be X minus 3. So H is going to be 3. Here it's Y plus 1. So Y minus negative 1 would make that Y plus 1. So again, it comes out opposite. Then R squared equals 25. So if you square root both sides there, you get R equals 5. So 3, negative 1 is my center, my circle with a radius of 5. So radius of 5 is 5, a distance of 5 from the center. And I'm just going 4 points and then do the best I can to make a circle with those 4. I probably could have done a little better, but there we go. There's a circle, kind of. All right, again, this one matches the same general formula, X minus H squared plus Y minus K squared equals R squared. So being familiar with that general formula helps me identify this as a circle again. This one I have a center HK, where the center, the H is going to be at negative 4 because you have X minus H, and positive 2 from the Y minus K. R squared here equals 49, so the radius will be 7, taking the square root of both sides there. So negative 4, 2, oops, that's not negative 4, 2, negative 4, 2, and then 1, 2, 3, 4, 5, 6, 7, distance of 7. And all 4 from the center, and then make the best circle you can. Note that even in these 2 examples, both my R squared values happen to be perfect squares, but it's not always the case. You could have R squared equals 6 per se, in which case R would be the square root of 6, which is approximately 2.3. So the radius is not always a whole number or perfect square value. It could be a decimal, in which case you just have to approximate there. Okay, the first thing I noticed about this is that it's just y and not y squared. That tells me that this is going to be a parabola. I only have 1 squared term, not 2 squared terms. Since it starts with y, this is going to be a parabola that is, the vertex will again be at HK, but this parabola's general form will be y minus k equals 1 over 4p x minus h squared. So then remember that the h is always with the x and the k is always with the y, so this will be negative 2, 5. There's still opposites here because it's x minus h and y minus k, so that's still going to be the opposite. So that's going to be the vertex of my parabola. Since this parabola is a y equals, and the general form is this, it's opening up or down. This particular one is opening up because the 1 over 4p is positive. It could be positive or negative 1 over 4p. If it's positive, it opens to the positive y. If it's negative, it opens to the negative y. Now we have our vertex. The next thing we'll have to find is our focus and our directrix. And that'll help us graph it. So that means we need to find our p-value. So if we look right here, we have 1 over 4p. In this example, it equals 1/8. So if 1 over 4p equals 1 over 8, p equals 2. That's just some mental math. 4 times p, 1 equals 8. So p has to be 2. You can cross multiply to solve for that as well. I'll show you that in the next example. So remember, this is opening up, so the focus has to be 2 up from the center. So you're going to go from the center up 2. That's going to be the ordered pair, -2, 5. We moved on the, -2, 7. We're moving on the y-axis, so I'm adding 2 to the y-coordinate to get that focus point. The directrix is going to be 2 away from the center, the vertex in the opposite direction, and the directrix is always a line. In this case, it's horizontal line, and it's y equals 3. So this time I subtracted 2 from that y-coordinate. Okay, if you remember how we define the parabola, the distance from the focus to the parabola and the distance from the parabola to the directrix always has to be equidistant. So if I draw my parabola through my vertex, opening up like that, this distance always has to be congruent with this distance, or this distance always has to be congruent with this one. And that's from any point on the parabola. These distances always have to be congruent. So I use this, since this distance was 4, I went over 4 and down 4, and that gave me a nice outline to draw my parabola the best that I could. All right, the next example again is a parabola, except for that this time it's x equals. So I know it's a parabola right away because it's only has one squared term, just the y is squared and not the x. This one is in the form y minus 8, or x minus h equals 1 over 4p y minus k squared. Again, this could be plus or minus 1 over 4p. If it's positive 1 over 4p, it opens towards the positive x's. If it's negative, it opens towards the negative x's. So since this is x equals and this is positive, we're opening to the right. The hk values, the h is always with the x, so that's going to be 2, and the k value is going to be 6. That's our vertex, 2, 6. So over 2, up 6. We're opening to the right. Now to find the focus and the directrix, we have to find the p distance. So our 1 over 4p in this example is equal to 4. So 1 over 4p equals 4, or 4 over 1, so that I can cross multiply. 4 times 4p will be 16p equals 1 times 1. P is going to equal 1/16. Now 1/16 is very small. Just going to use my calculator here and see if I could approximate that. I can't get it to pull up. Okay, 1/16 is a very small decimal. We're going to go, since it opens to the right, the focus is going to be 1/16 away there, and then the directrix will be 1/16 away on this side. It's going to be a very small distance, very close line. Since we're moving along the x-axis this time, to find the focus point, you're going to be adding 1/16 to that vertex point. So it's going to be 2 plus 1/16 will be 2 1/16, or 33/16 and 6. So that's that point right there. And the directrix will be the line, it'll be y equals, and you're starting at 2, this time you went back 1/16. So it'll be y equals, that'll be 31/16. As a decimal, that's like 1 and 15/16 right here. So a couple things, since this is a really large number out front, our leading coefficient, and our p-value is such a small number, this parabola is going to be very, very narrow. It's really hard to actually show the distance that's congruent from here to here because it's such a small value. So we're just going to do our best and sketch that. There, you could draw on your axis of symmetry, right down the middle there, and know that you're going to want to try to keep it symmetric, but very narrow. Okay, what if I wanted to write a couple equations? This one's a circle. It gives me the center. Remember, that's going to be my HK value, and it gives me my radius. So then I just need to remember my formula, and then just plug in those values. So it's going to be x minus -4 will be x plus 4 squared plus y minus 5 squared equals 6 squared, which is 36. So I'm just going to go ahead and put 36 right here. Got that from 6 squared. Pretty easy if they give you the HK. Sometimes they'll just give you the center and a point on the circle, and you'll have to solve for the radius. So if they give you the center of -4, 5, you'll plug that in for HK. And if they give you a point like 2, 3 on the circle, you'll plug that in for XY. And then you'd plug, so it looks something like this. So you plug in 2 for X and 4 for H, 3 for Y, and 5 for K. And this time you have to solve for R squared. So 2 plus 4 is 6. 3 minus 5 is going to be -2 squared, so that's going to be 36. Plus 4 is 40, so R squared. So if this was my example, be x plus 4 squared plus y minus 5 squared equals 40. So that's the equation of the circle that has this center but passes through this point. So that's a second added example there, what you might see. Okay, an equation of a parabola. It has a vertex at 1, -2, so 1, -2, and an x-intercept of 3. That's right here. So if the vertex is right here and it has an x-intercept, that means it has to be opening like that. It does tell me that it opens to the right, but just by my picture, I should have been able to tell that. That means I'm going to have, it's opening to the positive x's. I'm going to have the x minus h equals positive 1 over 4p, y minus k squared will be my general form of this parabola then. I know my hk, so that's going to be x minus 1 equals 1 over 4p, y plus 2 squared. If I plug in h and k into my equation. The only thing I'm missing is p. Now p is the distance from the center to the focus or from the center to the directrix. This particular problem doesn't give me the center or the focus or the directrix. If it did, I could just solve for this distance. Or if it gave me the directrix, I could find the distance from here to here. Without that, I'm going to use algebra. So they do give me the point, the x-intercept 3, 0. So that's the point xy. So I can plug that into my equation. So plug in 3 for x and 0 for y and solve this for p. So 0 plus 2 is 2, 2 squared is 4. 4 times 4p, that'll be 4 over 4p, which is really just 2 equals 1 over p. Then I can put that over 1, maybe do some cross multiply here. 2p equals 1, so p equals 1/2. So right here is my p. I have to plug that p equals 1/2 into this spot right there. So I'm going to get x minus 1 equals 1 over, well, 1 over 4 times 1/2. Well, 4 times 1/2 is 2. So it's going to be 1 over 2, y plus 2 squared. Again, I got 1/2 here by plugging 1/2 into this p spot right there. That's it for translating day 1. Thanks for watching.